Logarithmic scales. When we have an equation of the form y equals a log x, and this y is a logarithmic scale of x. For example, I already mentioned the pH scale. pH equals minus log of hydrogen ion concentration. Its pH is 0 when it's acidic, 7 for it's neutral, 14 for bitter basic. And this is concentration of hydrogen ion, but really it's concentration of H3O plus ion. Richter scale, similar deal. The Richter measure M is a common log of the quake intensity over S, which is a very small quake. Decibel scale is B is 10 common log of I over I naught. I is the intensity of sound in watts per square meter. I naught is a reference intensity of 1/1,000,000th of a watt per square meter. So, for example, find H3O concentrations for these two pHs, vinegar with a pH of 3.0 and milk with a pH of 6.5. Now, right here, we have pH in terms of concentration. To find concentration, we invert, get that the concentration equals 10 to the negative pH. So for vinegar, plug it in here, the concentration is 10 to the negative 3.0, 0.001, 0.1%. For the milk, concentration is 10 to the negative 6.5, which is 3.16 times 10 to the negative 7. All right. Now here they ask, if an earthquake is 20 times as intense as another, how much larger is its Richter magnitude? So let's say I1, intensity 1 is 20 I2. So I1 over S is 20 I2 over S. Take the logarithms, so they're equal. And this log of 20 I2 over S is a product, so it turns into a sum of logarithms. Log 20 plus log I2 over S. So log I1 over S, that's the Richter magnitude, equals 1.3, that's log 20, plus log of I2 over S. So the first earthquake is about 1.3 Richter points greater on the Richter scale. Here we have 1906 San Francisco quake reached 8.3 on the Richter scale. And there was a quake in Japan in 2011, 9.1 on the Richter scale. How much more intense was the second quake? All right, so we have two Richter measures, log I1 over S, log I2 over S. Their difference is the difference of logarithms, which will be a ratio of logarithms. Log of I2 over S divided by I1 over S. The S's cancel. M1 minus M2 is the ratio of the log of the ratio of the intensities. And then taking exponential base 10 on both sides, the ratio of the intensities is 10, the power of difference of the Richter scales. And all right, we already have them. 9.1 minus 8.3 goes into here. So the ratio is 10 to the 9.1 over minus 8.3. And after a bit of calculation, that's about 6.3. So the 2011 Japan quake was 6.3 as intense as the 1906 San Francisco quake. Here we have traffic noise. It's measured at 2 times 10 to the negative 5th watt per square meter. What's the decibels? Okay, the decibels is 10, common log of 2 times 10 to the negative 5th divided by the reference intensity of 1,000,000,000. 10 log 2.0 times 10 to the negative 5th over 10 to the negative 12th. Bit of calculator button pushing gives you 73 decibels for traffic noise. All right. Here a hairdryer noise at registering at 70 decibels. What's its intensity? As before, decibel equals 10 log of intensity over 10 to the negative 12. So we want to solve for I. First divide both sides by 10, then transpose a logarithm, get powers, base 10. 10 to the dB over 10 equals I times 10 to the negative 12. Transpose the trillionth, then get I equals 1/1,000,000th times 10 to the dB over 10. In this case, we put 70 for dB. So I equals 10 to the negative 12 times 10 to the 70 over 10. After a bit of calculating, that's 1 times 10 to the negative 5th watts per square meter. Okay, sounds good.